Here's Chemistry Unit 1. We're diving right in. This is podcast 1.1 for chemistry, and it's just on properties of matter. It's going to be really quick, really fast, and a lot of it should be review for you from physical science. So here we go. Properties of matter. Matter is defined as anything that has mass and takes up space. Write that down. Properties of matter. There are two types of properties of matter. There's intensive and extensive. Intensive properties are properties that do not depend on the amount. So for example, no matter the amount of salt, let's say that I have, the density of salt is always going to be the same. No matter the amount of water that I have, the density is always going to be the same. Hardness, specific heat, those are all things that it doesn't matter how much of it I have, how little or how much, the property or the value of these things are not going to change. So extensive properties are just the opposite. Extensive properties depend on the amount. It matters how much matter you have. So if I have mass definitely depends whether I have 10 grams, 100 grams, 1,000 kilograms. Mass is dependent on the amount of matter or the sample size that you have. Volume is the same way. Size is the same way. All of those things are going to change depending on the amount that you have. Make sure that you understand the difference between those two. Here's the next thing. We have 3 different phases of matter that we're really going to focus on. Solids, liquids, and gases. There's also plasma, but we're not going to talk about that a whole lot. So solids, liquids, and gas. Make sure you copy down this table. It will come in handy later on. We have movement, energy, shape, and volume. So if we look at each of these individually, movement, all solids are actually moving. The only time something is not moving, any matter is not moving, is when it's at 0 Kelvin. So all molecular motion has stopped at 0 Kelvin. That's the definition of 0 Kelvin. But if you think of the desks in this room or the furniture in your house where you think it's a solid and things are standing still, if you could look at it at a molecular level, you would actually see those little atoms vibrating in place. So they still do have some motion. Liquids have more motion. They're allowed to flow around each other. They have enough kinetic energy that they're moving and flowing, and that's what gives the liquid its properties that you see. And then a gas, they move even faster. So those atoms are flying around the room. Even though you can't see them, you can't feel them, they're moving very, very quickly. Energy, therefore, would be the least in a solid, greater in a liquid, and then the greatest in a gas. So if we think of shape and volume, shape of a solid, if I have a marble is not going to change its shape depending on the shape of the container that I put it in. I could put it in a mason jar like these. I could put it in a glass at home. I could put it in a vase. No matter where I put it, the marble is not going to change its shape. So we say it's definite, it's not changing. Liquids, however, will flow to take the shape of their container. If you put it in a mason jar, they flow to fill it up. They take the shape of it. You could put them on a plate and the liquid will spread out. So it's said to have an indefinite shape. It flows to take the shape of its container. And then a gas definitely is an indefinite shape as well. It will flow to take the shape of its container also. If we think of volume, the amount that we have, solids, the volume is going to stay the same no matter where we are holding that solid. So a marble's volume doesn't change depending on the container we put it in or the size of the container we put it in. A liquid's volume doesn't change. If I have 10 milliliters, let's see if I can do this. If I have 10 milliliters of a liquid in a really tall container, I still have 10 milliliters if I put it in a shorter and wider container. So 10 milliliters both places, it's not going to change. I still have the same amount of liquid, no matter the shape of the container. So that's also definite, it doesn't change. Gases, however, flow to take the shape and the volume of the container that they're in. If I have a container that is sealed off and it's a 10 milliliter container, the gas particles are going to spread out and their volume is going to be 10 milliliters. Then if I take that and I transfer it into, say, a 20 milliliter container, that 20 milliliters is going to be the new volume of the gas. So the gas has an indefinite volume. It flows to take the shape and it will take the volume of whatever container it's in. And that's what these pictures are representing down here. So if we look at this, the atoms are packed really tightly together. They're not moving. This is definitely the solid. The liquid, they have some motion. They're flowing around each other. They've taken the shape of the container. So that's the liquid. And then if we look at a gas, if we could see the atoms, they would be moving very, very quickly. There would be lots of space between them, and they would be taking the shape and the volume of the container that we're in. So those are representations of a solid, a liquid, and a gas. Make sure you draw those or something like those in your notebook so you can remember. These are vibrating in place, flowing around each other, and moving very, very quickly. And we shall clear my writing. Okay, so that's the end. Really simple, really short, should be a review from physical science.